Assalamualaikum warahmatullahi wabarakatuh. My name is SAKINAH binti NURAZMAN and my matrix number is 221373171, and I will start with the introduction of this PBL. So this experiment shows how an angle of a cube servo motor be auto adjusted by a digital control system created through LabVIEW and the NI device. This is aimed at achieving and sustaining a certain angle on the motor without any type of human interference. The system monitors the position of the disc by some feedback information of sensors and keeps on course by adjusting itself. This can be used to test the rate, precision and stability of the system whilst responding to a change, also an important concept in the day and age of automation and embedded control. Next, I will pass to the next presenter.
Good day everyone. Today I'll walk you through the circuit and flowchart designs for our project. Let's start with the flowchart. It begins with the user inputting an angle. This data is managed by LabVIEW control algorithms generating a PWM signal. The signal is sent to the NI hardware for input-output, driving the cube servo DC motor. An embedded encoder provides the feedback, which is compared with the user input. LabVIEW then analyzes the feedback, closing the loop for precise control. This process ensures the system adjusts dynamically to maintain the desired angle. Next, here's the circuit diagram. It starts with an input signal processed through components like the signals, conditioner and motor voltage. The circuit includes a comparator and filter with feedback loops to ensure accuracy. Key elements like the CL read and CL write block handles the data flow, while the output connects to a DC motor for execution. This setup ensures smooth signal processing and motor control.
Assalamualaikum warahmatullahi wabarakatuh. My name is TENGKU AHMAD NAQIUDDIN bin AMRAN. My number matric is 2213733185. So today I'm going to present the transient performance of our control system using peak overshoot and peak time as indicators. So these two metrics tell us how the system responds when we give a command, for example, to rotate a cube servo inertia disc to a target angle. As shown in our LabVIEW simulation output, we plot the system response using waveform chart and XY graph. So from the XY graph, we place the cursor at two places. The first one is peak output, where amplitude reached about 4.30 unit at 0.228 second, and another one is at steady state value about 31.388, also at 0.228 second. So using percent overshoot standard formula, our system reached the target by about 37.27% in only 0.228, as I mentioned before. This number suggests that the system is fast, but the overshoot also hint at a slightly underdamped behavior, which is expected when prioritizing quick response. It means that it is not unstable, but there is room for tuning if higher accuracy is needed in real-world application. This result support the stability and responsiveness of our closed-loop digital control system. It also proves that feedback from encoder is working effectively to control the motor position based on user input without manual touch to the disc. Overall, this analysis confirms that our system meet the design objective, which is achieving and maintaining the user-defined angle through a digital closed-loop control structure. Thank you. So that's all for me. Thank you.
Assalamualaikum and good day to everyone. My name is Sharuzqie bin SAARI. I'm going to present to you the new updated circuit design for this circuit. The major improvement in this version is the ability to manually input angle directly from the interface. This gives us more control and flexibility during testing. The input value passed through game block and summation for processing and then sent to the output using the HIL write block. We also added a collector and an XY graph to monitor real-time performance. This configuration is right around inside the control and simulation loops, which ensure real-time execution and process and response. Next, we have tested the circuit using an input of negative 45 degrees. The output response is shown here. On the waveform chart, we can observe the system's transient response. It initially overshoot and then stabilize as time progresses. The XY graph clearly shows how the amplitude changes over time with two different markers showing the data between 2 points. Those results confirm that the new circuit setup works correctly and is capable of handling negative input angle with stable tracking. Ini 45. Tak ada setengah off.
Layanan
Okay.